Welcome to the deep dive. We're going to plunge into some really compelling ideas from a stack of sources, pulling out those key nuggets of knowledge for you. Today, we are diving deep into something called Sophimatics. It's a pretty cutting-edge approach for designing and evaluating cognitive AI systems. Think of it like a framework, maybe, for building AI that doesn't just crunch numbers, but actually tries to understand and learn a bit more like we do. Our guide today is some fascinating research by Gerardo Iovani and Giovanni Iovani. They're really pushing the envelope on this Sophimatics idea for cognitive AI. So our mission really is to unpack how this whole framework aims to create AI that adapts dynamically, thinks flexibly, and also how do we even measure how well it's doing? Evaluate its performance rigorously.
Exactly. And it's not just about making AI smarter in a raw calculation sense. It's really about making it more interpretable, more adaptable, especially when things get messy or ambiguous out there in the real world. Sophimatics tries to do this by blending different strengths within AI, getting us closer to systems that can genuinely grasp what's going on.
That's a pretty big goal. Okay, so let's unpack the core, the mechanics here. The first thing that really jumps out from the sources is this term, hybrid symbolic-connectionist approaches. For someone maybe just dipping their toes in, what exactly does that mean, and why is it so central to Sophimatics?
Right. So at its heart, this hybrid approach is basically about combining the best bits from two major AI paradigms. You've got neural networks, people often call them connectionist models.
Okay, the pattern recognizers, the learning from data ones.
Exactly. And then you have the more traditional symbolic models. Think logic, rules, structured knowledge. So the symbolic parts are great for building up like context descriptions, understanding the situation abstractly. They can even provide rough solutions. And this is key. Doing that actually reduces the amount of training the neural nets need, makes them more efficient. The neural nets, on the other hand, they're brilliant at spotting patterns, even complex ones, and adapting when the data is maybe noisy or something they haven't seen before. And this isn't new, actually. We've seen this combo work well for a long time. Way back in the mid-90s, research showed hybrid approaches worked better for image analysis than just using one method alone. And we've seen that proved again in things like medical image recognition.
That's really interesting. So it sounds like a smart way for a cognitive AI system to handle different levels of abstraction. But is it really the best of both worlds? Or are there, big trade-offs when you try to glue these two different ways of thinking together?
That's a fair question, but the evidence, the empirical findings, they really do suggest it offers significant advantages in complex areas. That study I mentioned confirmed hybrid models outperform the purely symbolic or purely connectionist ones in recognition tasks. The symbolic abstraction part is really crucial. It sets the context. So the system isn't starting from zero every single time it sees something.
Okay. So it speeds things up.
It speeds things up, yes, but it also helps with interpreting sensory input and, importantly, generalizing better to new situations it hasn't encountered before.
Right. That makes sense. Now, you mentioned adaptability, and a common hurdle for a lot of current cognitive architectures is that they struggle to adapt, dynamically when the environment changes. This is where things get really interesting, I think. How does Sophimatics actually tackle this challenge, this dynamic cognition problem?
Yeah, this is a core part of Sophimatics. Its main idea for handling dynamic cognition is to explicitly merge those context descriptions from the symbolic side with the raw sensory data coming in. It does this through that symbolic abstraction level we were just talking about. It's not about static knowledge. It's about constantly learning and adjusting. It uses this concept called a hypobook. You can think of it like the AI's mental sketchpad.
A hypobook, okay.
Yeah. So when the system gets new information, maybe something ambiguous, it constructs different symbolic hypotheses about what it might be right there in the hypobook. Then it activates various neural networks specifically chosen to classify or test those hypotheses. And through this process, the system learns which relationships help reduce the ambiguity. It's actively trying to make sense of the unknown.
So it's almost like the AI is constantly generating theories like, is it this or maybe that, and then running experiments with its neural nets to figure it out. That sounds incredibly flexible.
That's a great way to put it. It becomes very flexible. It kind of reminds me of this idea Goldbrake talked about, where cognitive architectures treat knowledge like like bit strings that are constantly being updated based on interaction with the world,
Okay.
leading to this sort of bounded interaction. Sophimatics really embraces this, explicitly considering things like complexity, how much updating is feasible, and what level of error or noise is acceptable. Because a really good cognitive system, arguably, needs these kinds of recursive models, these processes that can learn dynamically as things change.
So if you have these complex systems that are learning on the fly, generating hypotheses, evaluating them must be tricky. How does Sophimatics actually approach assessing the performance? How do you measure how well these hybrid systems are doing their job?
That's a critical piece. Effective evaluation really needs an architecture that isn't just one black box. It needs different levels, distributed representations, like in neural nets, more localized ones, and those explicit symbolic modules. Having these layers is crucial for understanding why it's doing what it's doing. There are practical examples, like Vermeer and Leonard's work back in '89 on natural language processing, NLP.
Ah, okay. Language understanding.
Exactly. They were working on parsing noun phrases, understanding the structure. They built a hybrid architecture that combined error-tolerant connectionist parts with structured symbolic parts.
And what was so interesting there, you mentioned error tolerance.
Yes. What was really fascinating was that their system could parse correctly even when it tolerated a certain amount of errors.
Wow. Why is that explicit error tolerance so important, especially for AI in the real world, which is always messy?
It's vital because the real world is messy. Their experiments showed the hybrid system correctly parsed 88% of prepositional phrases it already knew.
Okay, pretty good.
But impressively, it still got 77% right for unknown phrases it hadn't seen before.
77% on unknown stuff. That's really telling.
It really is. It shows the power of combining that adaptive, error-tolerant processing from the neural nets with the structural understanding from the symbolic side. And this explicit error tolerance is a big differentiator for Sophimatics. Many traditional models have error rates, sure, but they're often implicit, hard to pin down. Sophimatics demands you define the acceptable error level explicitly. That allows for much more detailed diagnostics. You can see where it's struggling and make targeted improvements to recognition or classification.
So it's not just about getting the right answer, but understanding how robust it is, how it handles noise, and being able to diagnose it properly.
Precisely.
Yeah.
And it goes beyond just error tolerance. The Sophimatics evaluation framework also insists on looking at how the system handles complexity, ambiguous data, incomplete information, and crucially, it folds in an assessment against ethical guidelines. Are the decisions transparent? Is there bias? It aims for systems that are not just capable, but also trustworthy and responsible.
That ethical dimension feels increasingly important. So digging into the internals a bit, what does this mean for how the system actually handles those ambiguities internally and learns from mistakes?
Well, the way the neural nets and symbolic systems coordinate can be done within an integrated modular network. So going back to that noun phrase example, if the system misinterprets something, you can actually look inside. By analyzing the individual weights in the network, you might be able to pinpoint which specific attribute values led to the mistake.
You can trace the error back.
To a degree, yes. This level of internal visibility is incredibly useful for diagnostics and for refining how the system learns and makes decisions.
Okay, this whole hybrid approach really does feel like a significant step. But why is focusing on this combination so critical right now? Why not just pour all our effort into making pure neural networks even bigger, or refining symbolic AI on its own? What's the bigger picture?
That's a fundamental question. I think it comes down to the next phase of AI development. Someone named Hilario argued back in '96, actually, that just trying to recreate symbolic thinking using only neural networks might be kind of missing the point of what cognitive science and AI needed. He predicted that the real challenge, the next wave in IT, would be exactly these kinds of hybrid methods.
Interesting. So what are the key advantages that make it the next wave?
Two main things, really. First, flexibility coupled with, crucially, explainability. Hybrid systems, because they have those explicit symbolic rules, are just inherently easier for us humans to understand. You can often literally read the rules and follow the logic.
Which is almost impossible with a giant neural network.
Exactly. And that explainability isn't just a technical nicety. It's fundamental for building trust, especially if AI is making decisions in areas like medicine or finance. You need to know why. It also makes them easier to test and modify. The second big advantage is adaptability. When faced with something ambiguous or totally new, the system can use its symbolic understanding of the context to activate the right neural nets to figure it out. It also allows for dynamic resource allocation, only using the parts of the system that are best suited for the current task. That can be surprisingly efficient.
You mentioned efficiency. Hilario gave an example, right? Like interpreting the blue ball.
Yes. So the symbolic module would first analyze it, categorize it. Blue is a color, ball is an object. But here's the kicker. If the system already knows enough about blue balls symbolically, it might not even need to activate a complex neural network. It can just use the rule-based knowledge.
It takes a shortcut. That's smart.
It's about optimizing the whole cognitive process. So you have symbolic modules doing the abstraction, figuring out the general structure, reducing conflict, and then the neural networks, maybe operating within that symbolic framework, handle the fuzzy stuff. Ambiguous inputs, learning associations, recognizing complex patterns. It's a really effective partnership.
Okay, and there's another layer to Sophimatics, isn't there? It seems like it also weaves in human knowledge in a very direct way, using formal ontologies. How does that boost the system?
That's right. Integrating formal ontologies, basically,
Mm-hmm.
structured representations of knowledge about concepts and their relationships with the algorithms, significantly improves the AI's quality. It's like giving the AI access to a carefully curated, human-built library of concepts. It adds semantic depth. For example, Ultramari and Labir pointed to ACTR, which is a well-known cognitive architecture.
Right, models human thinking processes.
Exactly. They saw it as a good candidate for a Sophimatics-based evaluation platform because it's good at modeling how humans actually think, remember, solve problems. And a key tool here is something like WordNet. It's this huge open-access English dictionary and thesaurus, essentially. It has over 117,000 synsets.
Synsets?
Yeah, groups of words with similar meanings. Its struction helps the AI navigate language, improve searches, and spot potential ambiguities. Crucially, WordNet includes different senses of words based on how they're used and how frequently. This lets a Sophimatics system adapt its language interpretation based on context. It can figure out, okay, in this context, bank probably means a financial institution, not a liver bank.
Ah, so it gets that real-world nuance, like your example earlier, ball meaning a sports item versus ball meaning a formal dance.
Precisely. And that nuance comes directly from analyzing how humans use language, which makes it incredibly valuable for evaluating whether the AI is identifying meaning the way a human would. It even allows the system to consider if a sentence is so ambiguous that a human would probably be confused too.
That's a neat feature.
And there's also FrameNet, which focuses more on semantic roles, who did what to whom, based on linguistic frames. Again, derived directly from human language analysis, over 210,000 annotated units.
So by grounding the AI's understanding in the, let's face it, messy and nuanced ways we humans actually use language, it helps the AI reason more effectively, more like us.
That's exactly the idea. Ultramari and Libera basically said that efficient, scalable reasoning in language AI really only happens if the AI's internal processes mirror actual human cognitive activity, which perfectly aligns with the Sophimatics evaluation approach. It puts human-like understanding and process right at the center. So to wrap it up, the Sophimatics evaluation paradigm really rests on this foundation of hybrid symbolic and connectionist techniques. But it doesn't stop there. It explicitly pulls in insights from complexity theory, from ethics, and uses these rich ontological approaches grounded in human knowledge.
And all these different dimensions, the hybrid nature, the complexity handling, the ethics, the ontologies they have, to be explicitly acknowledged, right? That seems key. It ensures the system is adaptable, functional, actually aligns with cognitive science, handling the real-world complexity appropriately, and gives us enough interpretability plus that ethical check. Wow. This deep dive has really opened my eyes. It shows how intricate and thoughtful the next generation of AI development is becoming. It's clearly not just about building faster calculators, is it? It's about building machines that can understand, learn, and importantly, be understood. More like us, in a way. Sophimatics feels like more than just tech specs. It's a framework for accountable intelligence.
Absolutely. And it brings up a really important question for all of us to think about, doesn't it? As we push forward, trying to build these AI systems that can learn and adapt in complex, ambiguous environments, how might explicitly acknowledging and integrating ethical considerations right from the design and evaluation stages fundamentally change what AI becomes capable of? And just as importantly, how we end up interacting with it in our everyday lives?